Happy Monday, June 1st. I wanted to quick walk you through where we are and where we're headed. So if you look down the bottom here in yellow, we left off in March. We had completed systems of equations. When we started distance learning, we entered into geometry transformations, and there were 4 transformations. It was reflection, translation, rotation, and dilation. And once we finished that up, we then entered into the triangle sum theorems, the interior, and now today we're going to introduce the exterior. So as you can see, we are right on track with our curriculum. Next is going to be Unit 7. We will introduce volume of cone, cylinder, and sphere, and they're actually pretty simple. We give you the formulas. You would be given the formulas on any assessment regularly, and you just have to learn how to use those formulas. The only thing we're not going to get to this year is our statistics unit on bivariate data. And that's okay. If you take statistics in high school, it won't be probably until your junior year or so. And so a lot of this would be rusty, and you'd probably forget most of it anyway. So I felt like that was the safe unit to leave out if we had to leave one out. So going back, we are completing today the triangle sum theorem, the exterior theorem. You can see here this is Monday, June 1st. And then we're going to practice it tomorrow and actually assess it on Wednesday. It's a very simple theorem. On Thursday, I'm going to have you sign up for your groups for the epic scavenger hunt we're going to do here the last week of school. And it's kind of fun. It's going to be using Goose Chase, which is an app. There's a lot of unique and fun missions in there. And the prize will be a very unique custom designed Schoology badge that you'll be able to take with you to high school. It's a digital badge, and I will assign it to all the winners, and there will be several. So start talking to each other about what groups you want to make. There's a maximum 5 in a group, just because that's the way Goose Chase runs their system. So if you have like 6 friends or you have 7 friends in a group, you can just chunk it up into 4 and 3 or 3 and 3 and still work together. So then on Friday, we'll be going over the volume of cone, cylinder, and sphere, which is Unit 7, practicing it for a couple days on Monday and Tuesday of next week, assessing that volume, and June 10th is the last day we're taking grades. So if you have any outstanding work or want to update any of your assignments, now's the time to be doing it. On Thursday, we will kick off that scavenger hunt, and we will do that scavenger hunt through Tuesday, June 16th, and that will be the last day. I believe it closes at 8 o'clock that night to be able to do the last mission. There are over 40 missions, and I don't expect that you will do them all in one day. I estimated if you do 1 per teammate per day, you should be able to do a good bulk of those and earn plenty of points. And then on June 17th, the last day of school, I will be posting who the winners are and posting those badges to your Schoology classroom that you get to take with you to high school. So I hope that gives you a good feel for where things are going, that this is not an endless distance learning situation, but the end is in sight. Okay, so let's get on over to today's lesson. We need to back up a bit and review the idea of what a supplementary angle is. Supplementary angles are 2 angles, an angle pair. One is obtuse and the other is acute, meaning one is larger than 90 degrees in measure. So if I were measured from here to here, this might be, let's say, 140 degrees. Then if I got a protractor and measured this smaller angle, what would this measure be? Well, this would have to be 40 degrees because 140 plus 40 is equal to 180. Okay? But if you notice here, this almost makes a triangle itself. And you can have situations where this angle, this obtuse 140, is on the opposite side of a triangle. So what would these measures then be? Well, they also, because remember, we just learned the interior has to sum up to 180. Well, 40 degrees is already taken. That leaves me 140 degrees to split between those 2 angles. Now, I don't have enough information to know if it's going to be 70 and 70 or 60 and 80. But what I do know is that these two missing angles will sum up to 140. So let's go over that again. This was given to you that this is 140 degrees. And therefore we know that the smaller angle then must measure 40 degrees, because we know from the supplementary angles it has to total 180. So therefore the smaller angle must be 40 degrees. We also know, let's write that down. Supplementary angles must equal 180, right? So that's why we know the yellow angle has to be 40 degrees. We also know from the triangle sum theorem that the measure of all insides the inside angles must total 180 degrees. Therefore, when you add the two blue inside small angles, they will also equal 140 degrees. Right? Because 40 degrees inside is already taken, so that leaves me 140 inside. That is what the exterior sum theorem tells us. That the measure of this external angle is equal to the measure of the two opposite interior angles. Okay, I'll say that again. The measure of this exterior angle is equal to the measure of these two opposite side interior angles. Okay, let's take a look at what that looks like in practice. So if I said to you that this here was 60 degrees, you have to have something given to you, right? And this is supposed to be a straight line. So if that's 60 degrees, what is the measure of this big mamma jamma here? Well, that would have to be 120 degrees. And why is that? Well, because we know that the total sum has to be 180 degrees, right? Therefore, something, the unknown, minus 60 is what? It would be 120. Oops, I should probably have done that in blue, just to keep it consistent. Okay. Let me try explain that a different way. 180 minus 60 is equal to 120. Okay. So now I know that the big angle here is 120 degrees. Guess what the sum of these two angles will add up to be? It looks like a piece of pizza. It will add up to be 120. Now, I don't know. Could this be 60 and 60? Sure. Could this be 70 and 50? Sure, we don't know. But what will often happen when you practice and see these angles, in math class at least, is that they will give you one. They might say, well, this is 30. Well, then if that's 30, and I'm going to change color because I want this blue to only represent that exterior angle. If this is 30, then what is this? Well, it has to add up to be 180. So 60 plus 30 is 90. So therefore, this would have to be 90. Also, 90 plus 30 is 120, and these would match. Okay, let's do another one. Okay, so what we're trying to find is the measure of angle x. Well, I can say, well, let's figure out what is the measure of angle question mark first, and then use supplementary angles and we can determine what the measure of x is. So let's do it that way first. My first method is add 50 plus 55, which equals 105. And we know that all interior angles must add up to 180. So 180 minus 105, let's see, 100 would be 75, right? So now that I know that this is 75, I can use supplementary angles and say 180 minus 75 is 105. So now I know that x is equal to 105 degrees. So that's one way to do it. But that was a lot of steps. When ultimately, what have we learned? The exterior sum theorem says that if you add these two up, you know the measure of the exterior angle. So it would look like this. If I told you that this was 85 degrees, no, I'm not going to tell you what that is. I'm not going to make that 85 degrees. I'm going to make this 30, and I'm going to make this 40. No, I can't make it 40. That's too small. That would be acute. Let's make it 60. Nope, can't do that. It's a right angle. I'm struggling. Let's make it 80. That looks good. I don't have to find out the measure of this angle. This 30 plus 80 is 110. So guess what the measure of angle x is? 110. That's all we're trying to say today, is that the measure of the two opposite interior angles is equal to the measure of the exterior angle. Let's try another one. Okay, do I need to find out the measure of x to find out the measure of angle A? No, I don't, because I can add up the two interior opposite angles and find out the measure of angle A. So 59 plus 61 is 120. So the measure of angle A is 120. Okay? Okay, now let's use our newfound knowledge to find the measure of angle B. What is the measure of angle B? So there's two methods we could employ. Method 1, we can use what we know about supplementary angles and find the measure of angle A, and then use the interior sum theorem to find the measure of angle B. And that would be perfectly okay. However, we now know method 2. And that is just simply use the exterior sum theorem to find the measure of angle B. See how many less steps that is? So we know that 25 plus angle B is equal to 95. We know that the sum of 25 plus B is equal to 95. So 95 minus 25 is equal to 70. And therefore, we know that the measure of angle B is 70 degrees. Pretty simple, huh? That's why we have these theorems. They're to make our life easier, more efficient. Excuse me, I know that this has been a longer video than usual. I'm not going to give you any kind of exit ticket. I will give you a couple more problems here on the Ed Puzzle so that you can practice this. Tomorrow you will have a choice of methods of practicing this, and Wednesday we will assess how you're doing with it.